Hey everybody, Miss Terry is here, and today we're going to be dividing polynomials, this time with long division. So let's make math easy. Hope you're ready. Okay, so when we're doing long division, first of all, you can do long division on every single one of these. It'll work for all of them. It'll work for the ones that you do synthetic with, and it'll work with all of them, even the ones where you have missing terms. However, you must use long division when the divisor is not in x plus or minus c form. In other words, if x is to the first power and it does not have a coefficient in front of it, the coefficient is 1, then you're going to have to use long division. Okay, the remainder. What do you do with the remainder? Well, the remainder that you get after you do the long division, you're going to put it over the divisor at the end of your quotient. If you think about long division, you do end up with a fractional part that is added to what your answer was. So we're going to do the same thing. We're going to add it to our answer. And then here we have some examples that we're going to be trying. So there is a few things that we're going to review first. First, let's just go over long division. So we have a long division problem here. Notice your divisor. Keep note where your divisor is. We're going to take this and put it underneath the long division symbol. And then we're going to follow the rules. First, we divide. 31 divided by 5 is going to be 6. And then the next step says to multiply down. 6 times 5, so we take what is on the top, multiply it by the outside. What's on top, multiply it by the outside. Just keep in mind the steps. It'll make it easier when we start doing polys. Okay, so then we multiply. Next step, we just subtract down and bring down. And then the whole process starts all over again. We think to ourselves, what in the world can I multiply that divisor by that will get me close enough to 18 or either right on it? That's going to be 3. And then same thing, you multiply down, subtract down, and then you end up with your remainder. And if you recall the polynomials, you take your remainder and put it over your divisor. So I wrote this one in fractional form. So I get my answer, which is my quotient, but my answer is 63 3/5. Another thing that we need to go over before we start is subtracting polynomials. When we're subtracting polynomials, you have to think, remember, we changed that subtraction sign to a plus, and then we change the signs of every single term after that. Then you just follow the basic addition rules, you combine your like terms, and then you get your final answer. What's important here is just to remember that subtraction changes to plus, and then you change the signs of every term after that. Okay, let's try some long division with some polys. Okay, so here we have our first example. Okay, first step, we're going to take this problem and put it into the fraction bar. Same step we did before. And you notice that my poly up there is not missing a term, so I didn't have to compensate for that. So then we do the first thing. What's kind of going to give you a clue is look at this number here. We only have to deal with this number. Right now we can just forget about the positive 3. Well, that answer would be x. So you're thinking about what would I take and multiply by the 2x to get my 2x squared. So I'm missing an x. Okay, the next step in division is to take what is on top and multiply it by the outside. And you might recognize this as being distributive property. So I'm going to get 2x squared plus 3x. So I go ahead and write that down. 2x squared plus 3x. And then our rule says to subtract. Here is that thing with subtracting polys. Think of this as being a poly minus a poly. This would mean that I would change this to a positive and then change the signs of all of the terms after it. You might notice your opposites, when I add down, opposites are gone. And then I add down a negative plus a negative. I add and keep the sign. And then we have that same rule where you bring down. And then we will start the whole process over again. Okay, so what would I multiply? Remember to go to that outside number with the arrow out there. What would I multiply by that would give me a negative 20x? Well, I have my x term, so I don't need another x. So you can clearly see that's just a basic division problem, and I need a negative 10. So then, same thing, the distributive property, whatever's on the top times the outside. Whatever's on the top times the outside, I'll get negative 20x minus 30. And then we are subtracting a polynomial. Well, we know this has got to happen. I have to change my signs up. I have to change my subtraction and then add down. You'll see my opposites. And then I add down and I have a negative 8. Remember that you take your remainder, put it with your answer, and the remainder goes over the divisor. Okay, so how do you write that? So I take my answer, x minus 10, and I'm going to add my remainder over my divisor. And then here we have our final answer. So yes, your remainder is going to look like a fraction, but that's fine. That's what it's intended to look like. I always like to put the plus here because I like to think of my remainder as being something that I've added. However, you can write this as x minus 10, subtract, and then put the 8, and then over the divisor. Both of these things are correct. Okay, we're going to try another one. So I take my divisor and put my divisor on the outside, and then I'm ready for my fraction bar, and I look in this poly, and in standard form I'm missing my x term. I have my constant, but I'm missing the x term. This is a great example of what happens when we have missing terms. What do? So if you have a missing term, you put a 0. Put a 0. So here I'm just going to add a 0x, just for a placeholder, but you have to do it. It's important. If you forget the 0, then you're going to miss the problem. So make sure that you put your missing terms, put your 0. Now I'm going to go back to the same process. 7x times what is going to give me the 42x? 7x times what will give me the 42x? That's going to be 6x. Then I do distributive property. 6x times the outside. So I have a 42x squared. And then I have a positive 42. Next step is to subtract down. When I subtract down, that is really the same thing as adding the opposite. These are going to be gone. And then I add down and get a negative 42x, bring down, and then I'm ready to start over again. So 7x times what will give me that? I need a 6, and I need that to be negative. So now I have my negative 42x that I'm looking for, and then I have a minus 42. Subtract that poly. When you subtract the poly, you're really adding the opposite. There's my opposites I'm looking for. That's the whole point of long division. We want that first term to cancel out. And then when I add a negative 33 and a positive 42, I get 9. So now I'm ready to write my answer. My answer is up there at the top. 6x minus 6 plus my remainder over my divisor. Throw me a box around this. Final answer, 6x minus 6 plus 9 over 7x plus 7. Hope you enjoyed seeing 2 versions of long division. Thank you so much for viewing. And don't forget to hit that subscribe button. And if you are interested in live tutoring, you can always hit me up on tntcenter.com. Thanks. Bye, guys.